cooperate. Oop. I know you have learned about water before, so hopefully this is going to be a review, or maybe you'll learn some new words, but I'm going to go kind of quick. Feel free to pause if you need to write something down. Here are the 5 properties of water that you have in your notes and that we are going to see coming up. This is just the list version. Here is the first one. Water is polar. And what does that mean? Water is polar means that there is an uneven distribution of electrons. In water, water is H2O, right? The oxygen, which is this red one, it likes electrons a lot. It likes them so much that it will pull them straight off of those little hydrogens. Remember that electrons are negative charge. So since more electrons are hanging out with the oxygens, they end up having a negative charge. And since less electrons are hanging out with the hydrogens, they end up having a positive charge. And that little bit of attraction between negatives and positives is kind of like a magnet that makes water molecules stick together. That's hydrogen bonds. You've seen them before when we did notes way back at the beginning of this unit. But the reason why water can do a lot of the things that it does is because hydrogen bonds. Cohesion is when 2 of the same molecules bond together. Adhesion is when 2 different molecules bond together. This is hydrogen bonds. So if you see water droplets, that's cohesion because it's water sticking to water. If you see like water sticking to a paper towel, that would be adhesion because it's water and towel, 2 different things. They're the same idea, just cohesion is the same, adhesion is 2 different. Why? Hydrogen bonds. Surface tension. If you see water that forms a bubble like that, that surface is what we're talking about. It's how much force do you need to put on it before it breaks. Water has very high surface tension, which means that little animals like this little guy can walk on it. Now, they're very small. They're like an inch, itty bitty tiny little bugs. Those are called water striders or Jesus bugs because they can walk on water tension. The reason that you float is something different. That has to do with the oxygen in your lungs. Ice floats. Duh. Like, go put some ice in your drink and see what happens. When water freezes and becomes ice, the hydrogen bonds push the water molecules apart so it gets bigger. This is also why in the wintertime we have potholes, because water gets in the little cracks in the road and then it expands and makes big holes. What this also means is inside of all these little shapes, air can get trapped in there and ice can float. Okay, well, why do we care? We're in biology. Why are we talking about ice? Well, if you're a living thing that is in water, then all of the ice will float and the water underneath stays water. That way, if you're like a seal or a penguin or a polar bear or something, you can swim underneath. The water underneath doesn't freeze. You can still live in it. It doesn't freeze solid. Specific heat means how much heat do you have to put in to make it change temperature. If you try to heat up water, it takes a while. If you try to put water on the stove to make something, it takes a little while. It takes longer than other liquids do. This means water can hold a lot of heat. Again, why do we care? We're in biology class. Why do we care about this? If you live in water, or if you are made of water, like we are, then water won't just boil or freeze. You don't have to worry about all the water inside all of your cells freezing solid. Because water takes a long time to change temperature, that means that our bodies can stay pretty normal, and also liquid water can stay pretty normal, so all the fishes can survive. Water can dissolve almost anything. If it does mix with water, then that means that it is hydrophilic. Go ahead, you can come in. Hydrophilic means that hydro is water, philic means love, so this means that they do mix with water. This would be like sugar, salt, most molecules. Hydrophobic means that it is water fearing. We've seen this word before because this is what fats and lipids are. They do not mix with water. pH is the last thing on your notes. Water can break apart. And also other molecules can do this too, but water definitely can. Where they will make OH and H. You can see like it had oxygen and 2 hydrogens and it breaks apart. If a solution has more hydrogen in it, then that is an acid. If it has more of this. If it has more of this, then it's a base. Last thing, so on your paper, you're going to write down this part over here with the arrows over on the left side. If something is pH of 7, that means it is neutral, it's pure water, it's not an acid or a base, it's just plain water. If it is less than 7, 0 to 6 or 6 to 0, that means it's an acid. If it is above 7, 8 to 14, that means it's a base. So these things that are pretty close to 7 they're weaker acids and bases. So like coffee. It's an acid technically, but it's not very strong. You can drink it, you'll be fine. Eggs, baking soda, toothpaste, like these things, they wouldn't hurt you. But the dangerous acids and bases come in way up here and way down here. Once you get to pH 0 or 14, those are the ones you want to avoid because they can really hurt you. They destroy your cells. They can cause burns and all kinds of other nastiness. We're not going to have a secret word today because I'm doing this very fast and the custodians are trying to get in here to clean the floor. That's who was here before, so I got to finish up and get out. But real quick, what should we know about water? You should know that water is polar, so it makes these bonds, which creates things like cohesion, adhesion, surface tension, ice floating, water holding a lot of heat. You should know that water dissolves almost everything. If it does dissolve something, it's called hydrophilic. If it does not, that's hydrophobic. And the pH scale. What's an acid and a base? What does that mean? Got it? Okay. We still have a little bit further to go in this unit. We got to do photosynthesis and cell respiration still. So we're 3/4 done. Hang in there. Keep your notebook going. See you next time.